Greetings everyone, this is Mr. Mull, and this is a quick video just showing some hints for help on this worksheet 3, ionic concentrations. For all of these problems, the first thing you need to do is you need to find the molarity, and that's going to be the number of moles per liter of your solution. And so you just take the number of moles divided by the liters of total solution, but you must have moles and you must have liters. The second thing you need to do is you need to write a dissociation reaction or equation, and that just is showing what the ionic compound breaks apart into when it's dissolved into water. And then the third step is we're going to determine the concentration of each individual ion as it's floating around. And so question number one, we have sodium chloride, we throw it into water, and what happens is it gives me the molarity of sodium chloride. Okay, so if I had a liter of this solution, I would have 0.01 moles of sodium chloride that would be dissolved in there. And so because every single one of those NaCl's, when it breaks into water, gets yanked apart, it gets pulled into an NaC, Na plus, and a Cl minus. And looking at one of these, it's going to break into one of these and one of these. Okay, and using some stoichiometry, we're just going to say, okay, well, if I have 0.1 moles of this, then I'm going to have 0.1 moles of this and 0.1 moles of this floating around. And so the final step is just going to put in the little brackets here, Na plus, that little bracket just means the concentration of, and we can go ahead and find our concentration. Number 4, a little bit different. They give you grams and they give you milliliters, and so the first step is to find the molar mass of the compound, and once you do that you can convert to moles. And then the first step is find molarity right here. So take the number of moles total divided by the liters of solution. So I have to divide my 250 by 1,000 to get there. And then I get my molarity of my sodium carbonate. And so when I throw that solution in water, we're going to assume for this worksheet that all of these are strong electrolytes. That means every single one of those ionic compounds, formula units, is going to break apart in water. And so when I look at my dissociation reaction, I'm going to be very deliberate that one of these is going to break apart into 2 Na pluses and 1 CO3 minus 2. Those are the ions that make up that ionic compound. And so when 1.7 moles of that compound dissolve, then that means twice as much, because that Na is actually 2 pieces, it's going to be 2 times 1.70. The other way you can think about this is if this were x, this would be 2x, this would be x, and if you know what x is, it's just 1.70. You can just go ahead and therefore say, okay, well, Na plus is 2 times that value, 3.40, and then carbonate is just going to be 1 times that value, or 1.70. The last hint I wanted to show you was for number 10. Number 10, I just kind of did the beginning of the problem. There's 2 sources of solute that are going to be totally in here. And so you take 32.5 grams of KCl, and you pour that into a solution that already has 5 moles per liter of KCl dissolved in it. And so what you need to do is you need to add the moles from the solid you added plus the moles already in there. And so I'm adding in a solution here. I want you to assume a negligible volume change, because otherwise we'd have a new volume. The volume would change too. So we're going to assume the volume doesn't change a whole lot. And so I'm going to still divide. When I find my molarity, we're going to assume that the volume doesn't change a whole lot when we add that. So I find my moles from the powder plus the moles that were already in there, and then I can find my new molarity and go from there. And so this is to find the concentration of different ions. Assume for all of these that they are strong electrolytes, and I hope that this was helpful.